More on categorical predictors, and we're going to shift gears now and consider categorical predictors with more than two levels, using only zeros and ones. Fun stuff, right? So let's take an example. What if we had facility A, facility B, and facility C in a study to handle dummy variables for a categorical predictor with more than two levels? We first have to set a reference level. And, that can be selected a lot of different ways. It can be guided by the research question. A lot of researchers will just choose the facility, in this case, with the highest sample size. Sometimes people just throw it in R and let R decide. But for the sake of this illustration, I'm going to set the reference level at facility A. So that's the first thing we have to do, set a reference level for the categorical predictor. The next thing we do, we think about K being the number of levels, and in this case it's 3 because we have facility A, B, and C. We create K minus 1, or 3 minus 1, which is 2, dummy variables consisting of only zeros and ones. So since facility A was our reference, dummy variable 1 is going to be facility B to facility A comparison, and dummy variable 2 is going to be facility C to facility A comparison. This is why we have 2. We take all of the remaining facilities and we compare each one of those to the reference category, the reference facility in this situation. So dummy 1 will consist of zeros and ones, and dummy 2 will consist of zeros and ones. Now, if you're working in R, it works out nicely. So what we do here is, first thing I want to do is I'm considering adding hospital. Again, go back up to the data set, and you can see the hospital is the only categorical variable that we have with more than two levels. So it's kind of forced to choose it. And so if I'm considering adding hospital to the model, the first hospital that comes up when I run table is almost always, in fact I've never seen it work otherwise, the reference group. So when I run this model, it's going to compare north to east and south to east. So because it's categorical, I want to force it as a categorical predictor, and I do that with the factor command. And then I'm going to run my model 4, which has age, HF underscore SCI, gender, and hospital added to the model. And look, you can see our standard errors are kind of high and kind of wacky, so that probably has to do with we have too many predictors in this model. 15 cases per predictor, right? We only have 43, so we're violating a lot of stuff. But again, this is just a demonstration on how we put or enter categorical predictors with more than two levels in our model, and how we interpret the output. Okay, so what I have here, just as expected, East has been selected by R to be the reference group. So this compares north to east, and this line right here compares south to east. Now, what happens behind the scenes with these zeros and ones is the following. If we're setting A as the reference group, then A to A is a redundant comparison. So every place I see A, I come in and I put zeros and zeros. Dummy 1 compares B to A, so every time I see a B in dummy 1, I'm going to have a 1, zeros otherwise. Dummy 2 compares C to A, so everywhere I see C, I have to have a 1 there. So I essentially create two new variables. Again, K minus 1, 3 levels. 3 minus 1 is 2. I create two dummy variables because of the the K levels, or I'm sorry, the 3 levels that we have in this example. Now, circling back over to the hospital north, hospital south, and hospital east, R will default to the level for the first case. Actually, that's not true. It doesn't. It defaults to, when you run the table, to the category, the reference level that is presented first. This will give you a really good idea. And there is a way that this can be changed. But I'm not going to talk about that in this video. So with if we set, again, going back up to this example, sorry I'm jumping around, but if we set A as a reference group, then I can compare B to A and C to A, but I cannot compare B and C. So circling back over to R, if I want an interpretation for the hospital north coefficient, so this one right here, being consistent with what we've done previously, I would say controlling for the other predictors in the model, controlling for age, HF, SCI, gender, and south to east comparison, because it's in my model. The predicted SSQ for north is 0.76 units lower than for east. Again, whatever I'm given right there, north is compared to east. South is compared to east. Just like male was compared to female. So again, zeros and ones, this is what we get. So again, in R, as long as you kind of luck out and get your reference group, this can easily be changed if you move your data into Excel and just take a case and set the first case as the reference that you want. R almost always recognizes it. And there's also a way to relevel your variable, and I can demonstrate that to you as well, and I will. Now, what happens in a stack crunch? Yeah, this gets a little crazier. So it's going to take some time. So I am going to upload that in the next video. Take care.